Hello everyone and welcome. In this presentation, we will explore the concept of chaos engineering specifically applied to databases. We will uncover how intentionally introducing controlled failures can lead to more resilient and robust database systems. Our focus will be on building confidence through resilience testing. So, what exactly is chaos engineering? At its core, it is the discipline of experimenting on a system by deliberately introducing controlled failures. The goal is to build confidence in the system's ability to withstand turbulent conditions in a production environment. Think of it as proactively testing how your database systems respond to unexpected disruptions before they actually happen in a live production setting. By simulating failures, we can identify weaknesses and improve the overall stability of our databases. Now, let's discuss why chaos engineering is particularly important for databases. First, it helps prevent outages. By identifying weaknesses in your database systems early on, you can address them before they lead to production incidents and costly downtime. Second, it improves resilience. Chaos engineering enables you to build more robust database architectures that can withstand unexpected failures and recover quickly. Finally, it validates assumptions. It allows you to test whether your failover, backup, and recovery mechanisms actually work as expected under stress. This ensures that your database is prepared for any eventuality. To effectively implement chaos engineering, it is important to adhere to a set of core principles. First, always start with a hypothesis. Begin with a clear idea of how your database system should behave under specific failure conditions. For example, hypothesize that if a primary node fails, the system will automatically fail over to a secondary node within 30 seconds. Second, define a steady state. Establish measurable metrics, such as throughput, latency, and error rates, that represent normal database operation. These metrics will serve as your baseline for comparison during chaos experiments. Third, minimize the blast radius. Start small and contain any potential damage. Run experiments in controlled environments before moving to production. Use circuit breakers and timeouts to prevent cascading failures. Finally, automate experiments. Create repeatable, automated tests that can be run regularly to continuously verify system resilience as your database architecture evolves over time. Let's take a look at some common database failure scenarios that you can simulate with chaos engineering. First, node failures. Simulate complete node crashes or restarts to test failover mechanisms and recovery procedures. Second, network latency. Introduce network delays between database nodes to test how replication and queries perform under degraded conditions. Third, network partitions. Create network splits that isolate database nodes to test split brain detection and partition tolerance. Fourth, resource exhaustion. Consume CPU, memory, disk input-output, or connection pools to test how systems behave under resource constraints. Fifth, replication lag. Force replication delays to test how applications handle eventual consistency and stale reads. Finally, lock contention. Create deadlocks or high lock wait times to test timeout handling and retry mechanisms. Implementing database chaos experiments involves a series of well-defined steps. Start by defining the experiment scope. Clearly define what you are testing and establish success criteria. Then measure baseline metrics. Collect performance data during normal operation to compare against during the experiment. Inject failure. Introduce the planned failure using chaos engineering tools. Finally, observe and analyze. Monitor system behavior and collect metrics during the experiment. The code snippet shows an example of how to simulate database node failure using Chaos Toolkit. It defines an experiment to test if the database is available when primary node fails. It specifies a probe to verify if the database responds and sets the tolerance to true, indicating that the database should be available. Fortunately, there are a number of tools available to help you implement chaos engineering for your databases. Chaos Monkey, Netflix's original chaos engineering tool, randomly terminates instances in production to ensure services can handle instance failures. It is best suited for cloud-based database deployments. Chaos Toolkit is an open-source framework for chaos engineering with extensions for various platforms including databases. It allows for creating custom experiments, making it ideal for custom database failure scenarios. Gremlin is a commercial platform offering controlled chaos experiments with a focus on safety. It provides specific database attacks for MongoDB, Cassandra, etc., and is best for enterprise database environments. Toxaproxy is a proxy for simulating network conditions like latency, bandwidth restrictions, and connection failures between database components. It is useful for testing network-related database failures. Pumba is a chaos testing tool for Docker containers. It can kill, stop, or remove containers running database services to test resilience, and is best for containerized database deployments. Chaos Mesh is a cloud-native chaos engineering platform for Kubernetes with specific database fault injection capabilities. This makes it suitable for Kubernetes orchestrated databases. To conclude, let's cover some best practices for implementing chaos engineering. Start small and gradually increase the complexity of experiments. Always have a rollback plan in place before starting an experiment. Run experiments during business hours with engineers available to respond to any issues. Document your findings and share knowledge across teams to improve overall system understanding. Integrate chaos experiments into your continuous integration and continuous delivery pipelines to ensure ongoing resilience. Monitor and measure everything during experiments to gain valuable insights. Chaos engineering for databases is not about creating chaos, but about building confidence in your systems through controlled experiments that reveal weaknesses before they cause real outages. The goal is not to break things in production, but to discover and fix issues before they break in production on their own terms. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.